Simplifying expressions with exponents. To begin, let's look at some of the laws of exponents. The product rule states that when multiplying two expressions with the same base, you can add their exponents. For example, 3 squared times 3 to the third power can be rewritten as 3 to the 2 plus 3 power. This becomes 3 to the fifth power, which is 243. The quotient rule states that when dividing two expressions with the same base, you can subtract their exponents. For example, 4 to the fifth power divided by 4 to the third power is just 4 to the 5 minus 3 power. This brings us to 4 squared, which is just 16. Keep in mind that these two rules only work when the bases are exactly the same. The power of a product rule states that when a product is raised to a power, each piece is raised to that power. For example, given the quantity of 2x to the third power, we know that the 2 and the x in the parentheses are being multiplied, so we can raise both of them to the third power. We get 2 to the third times x to the third, which can be simplified to 8x to the third power. The power of a power rule tells us that when raising a power to another power, you can multiply the exponents. So our example of x squared to the third power can be rewritten as x to the 2 times 3 power, which is just x to the 6th power. Now let's look at negative exponents. A negative exponent simply means move this term to the other side of the fraction. If the term is in the numerator, we can move it to the denominator and make the exponent positive and vice versa. For example, x to the negative second power divided by 8 can be rewritten by moving the x term to the denominator and making the exponent positive. Keep in mind that there is technically a 1 in front of the x, so when the x moves, there is still the number 1 in the numerator. We then arrive at 1 divided by 8x squared. You can even move two negative exponent items at the same time. So for example, 3x to the fifth, y to the negative fourth power, divided by z to the negative 1 power, can be simplified by moving the y and z bases, which gives us 3x to the fifth power times z divided by y to the fourth power. Sometimes we won't have a fraction, like with this term, x to the negative third power. Remember that you can create a fraction by putting it over 1. We then have x to the negative third power, which then becomes 1 over x to the third power. Let's practice. We are given x to the ninth, y to the third, z to the eighth, divided by x to the fourth, z to the seventh. We must remember that when dividing two items with the same base, you can just subtract the exponents. So we can deal with the x base and the z base at the same time by saying x to the 9 minus 4 power, y to the third, z to the 8 minus 7 power. Then we can simplify the exponents to get x to the fifth, y to the third, z. Here is another example. We are told to simplify the following expression and to make sure that all the exponents are positive. We are then given the quantity of 8x to the fifth power, y to the negative third, all to the second power. Let's multiply our exponent to the exponent on each item. So we then get 8 to the 1 times 2, x to the 5 times 2, y to the negative 3 times 2, which, after multiplying, is 8 squared, x to the 10th, y to the negative 6th power. We can solve 8 squared to get 64, x to the 10th, y to the negative 6th power. Then let's move the y base to the denominator and make the exponent positive. So we end up with 64 x to the 10th divided by y to the 6th power.